This just gives you factored form right here. And factored form is going to be like sets of parentheses. It might have just a greatest common factor. It might be a couple sets of parentheses, something like that. Factored form and then also standard form. So if I were to FOIL that out and get rid of the parentheses, then this is equivalent in standard form. So they're equal to each other, and typically for just purposes in general, especially if you're solving an equation, the factored form is what you would ideally like to have to solve an equation, but we're just going to practice going back and forth between the two forms today is really what we're going to do. So the problems at the top, these are probably, they're not bad, but I'm not going to lie to you, they're a little bit time consuming. So we are going to take factored form in this first example and put it in standard form. Okay, now the main thing people kind of mess up here is they try to multiply like all three of them together at once. You don't want to do that. So you can do this in any order. This is just my recommendation. I just do two at a time, and I usually just do the two that are on the end of the problem. And then what that'll create in that situation a quadratic. And then I go back, and it's basically like the last example we were doing yesterday. I'm going to multiply x plus 10 by the result. But you just want to multiply them, just do two at a time, so we don't get too many terms going here. So however you want to do this, if you want to do like a little box or a FOIL, I'm just going to do a little FOIL on mine, or double distributive properties, how I think about it. Now remember, you're going to multiply the numbers and you're going to add the exponents on the letters that are the same. So if I do 2x times 3x, we're going to get 6x squared. 2x times 4 is 8x. 5 times 3x is 15x. And 5 times 4 is 20. You can always multiply, but you can't, you got to add and subtract only like terms. So I'm just going to simplify this just a touch. This would be x squared. Now in here, my 8x and my 15x, we can add that together. So that would be 23x's plus 20. And then I have not used yet the x plus 10, so I'm just going to bring that down. Now, this is kind of like I said, the last example we did yesterday was kind of like FOIL on steroids, or if you want to draw yourself a box, just draw yourself a box that has like a 2 by 3. I just do everything times x, and then I'm going to do everything times 10. So this is just going to change your exponent. So that's going to become 6x cubed plus 23x squared, and then plus 20x. Now you don't have to do this, but this is how I do it. I just multiply by 10, and I try to line up the like terms. That's why I'm doing this in a different color. So if I do 10 times 6x squared, that is 60x squared. So I just write it underneath the other term with the x squared just to make it faster to combine like terms. If you want to use that, you can. You don't have to. 10 times 23x is going to be 230x, and then 10 times 20 is 200. And then I'm just combining like terms here to get my final answer, and this will be the polynomial in standard form. So I got 6x cubed, we have 83x squareds, I've got 250 x's, and I've got 200. If you want to name that, you don't have to, but that's going to be a cubic polynomial with 4 terms in it. Is anybody having a question? Okay, now the second problem here is basically the same thing, but a little bit smaller coefficients, because I'm just going to have an x. The main thing I want to say to you on this question, if you have something that is squared, which I do, or to the third or something like that, do not distribute the exponent. Okay, don't write like x squared plus 9 or something like that, because you completely miss out on the middle term. Anytime you have adding or subtracting inside parentheses and it's got an exponent, I would just tell you, let's just write it however many times the exponent is. Because if you don't, you're not going to get all the terms correct. So x minus 3 squared is the same thing as x minus 3 times x minus 3. So don't forget to do that, because if you distribute that exponent, you're going to completely get the answer wrong. So I would set it up like that, and then I'm just going to do it exactly like I did the previous question. I just do 2 at a time. I usually just do the 2 on the far right first, and I'll leave that x plus 4 out in front. So I'm just going to do the same thing, just a little box or FOIL, however you want to do this. You should get x squared minus 3x. then you get another minus 3x, and then negative 3 times negative 3 gives you positive 9. So you see, if I just tried to distribute that exponent, sorry, I'm going to sneeze, I would completely miss out on that middle term at that negative 6x. So that's why that would be incorrect if you just kind of distribute the exponent. You're not going to get all the terms there. Then, all I'm going to do, just bring down, we haven't used the x plus 4 yet that was at the beginning of the problem. And then this turns into, like I said, what we were doing yesterday, where it's like foil on steroids. We're just going to do triple distributive properties. So I'm going to do x times all those. If you like the box, feel free to draw yourself a box. If you prefer that little bit more visual way, I'm just going to do this to save some space here. All right, so I'm going to get, all I'm going to do when I multiply by x, we're just going to change these exponents. So I'm going to get x cubed minus 6x squared plus 9x, just adds an x to each one of the terms. And then I'm going to go through multiply everybody by 4. So we're going to get 4x squared minus, what, 24x, and then plus 36. And I just try to kind of, like I said, stack the like terms on top of each other to make it easier to combine like terms. I only have one term with an x cubed, so nothing to combine that with. Negative 6x squared and 4x squared is negative 2x squared. I'm positive 9x minus 24x would be, don't judge, negative 15x. I think that's right. And then 36, that's the only plain number, so there's nothing to combine that with. And that would be my polynomial in standard form. Standard form just means you're going to get rid of the parentheses and multiply everything out. Okay, is anybody having a question? Okay, that's factored form to standard form. Now we're going to go backwards. So I'm going to give you standard form, and you're going to see if you can put it in factored form. So each one of these says completely factor, so we're going to get into that in a second. But every single one of these examples has a greatest common factor in this particular set of examples. That's not always the case, but I do have it here. So first thing you should always check for, do I have a greatest common factor? So what do 3x cubed, 18x squared, and 24x all have in common? 3x. Okay. So somebody raise your hand and tell me. If because I don't have an equation here, if I take a 3x out in front of each one of those terms, who could tell me what would be left if it's like undoing a distributive property. If I pull out that greatest common factor, what would be left? Go ahead. Perfect. X squared minus 6x plus 8. Okay, now, not always, but generally speaking, if you see something in the directions that says completely factor, what it's trying to imply to you is probably whatever you had in the parentheses could be factored a little bit further, which is totally the case for this question. So if this is just back to two sets of factors here. Now I'm going to write this. So it's multiply A times C, add to B. In this particular one, I'm just looking inside the parentheses. So my A value would be 1, my C value would be 8. So I would want two numbers that would multiply to get 8, and then add to get the B value, which is just that negative 6 attached to the x. Both factors should start with x. X times x will give you x squared. So just take that first term, drop the squared, put it at the beginning of each of the factors. What two numbers could you make multiply to get positive 8, but add to get negative 6? Negative 4, negative 2. Does not matter which one comes first or second. So you could put the x minus 2 first or the x minus 4 first. Doesn't matter as long as you have both. And then this is what, we can't go any farther. This is what we would call completely factored form. I'm not solving an equation here, so I'm not writing answers. You see no equal sign. We're just practicing with factoring here. Okay, now each one of these is a little different. What do 2x to the 4th and negative 50x squared both have in common? 2x squared. Good. So they have at least x squared, and both of those are even numbers. So I'm going to pull a 2x squared out in front. Can anybody tell me what would be left over if I factored out 2x squared? So if I divide both by 2x squared, what would you have left in the parentheses? What did you say? X squared minus 25. Okay, now, it's been a minute. Inside the lovely little parentheses here, I don't know if you guys will remember doing this. This is called a difference of squares. can you think here, I know there's not 3 terms, but this can be written as 2 factors here. So I need to multiply, in that case, my C value is -25. I don't have a B value. It's called a difference of squares, if you remember the little formula for that. Or if you could tell me 2 numbers that when you multiply them you get -25, you add them up, they would be 0. One of them's -5, one of them's +5. It does not matter which one comes first or second. You can switch the order of those, but that's called a difference of squares. So that's your completely factored form. All right, and I have one more. This one's probably going to be the hardest. What do 6x to the 4th, 40x cubed, and -14x squared all have in common? 2x squared, I heard somebody say. All right. Now, what I'm doing is you don't have to write that if you don't want to, but I'm going to pull that out in front. That's just pulling out the greatest common factor. So if we take a 2x squared and divide that out of each of the terms, what would I have left? (3x squared plus 20x plus what? Or -7. Perfect. Okay, now, this is the one that I said this will be the trickiest. All right, so if you guys remember, if you have a number in front of the x squared, I'm just going to remind you how to do this. And if you want to do it a different way, if you like factor by grouping or something like that, feel free. I'm going to take a times c here. I'm going to use that Berry method and review that with you because that's my favorite. You have to take the first, like the 3 and the -7, multiply those together because the a value in each of these previous questions is just 1. All right, so 3 times -7 is -21. And add to the middle number, which is 20. Now, here, the little trick, I got to leave this 2x squared out in front. The little trick to the method, if you do this, if you have a number in front of the x squared, you are going to take that first term, which is 3x squared, you're going to drop the squared, and you're going to put that into each of the first, this won't be the answer, but put that in the beginning position in each of those factors. Then we're going to fill those factors in with numbers that multiply to get -21, but add to get 20. Can we think of 2 numbers that could make that happen? What do we think? I feel like somebody said it. Do what? Yes, okay. So if you do -1 times 21, right, and -1 plus 21 would be 20. All right, so it doesn't matter which one comes first or second. One of them should be -1, and then one of them should be plus 21. Now, it's been minutes since we did this. Don't forget, this does not multiply, like if we were to FOIL or box this, that does not give me what I have there. If you are working with a number in front of the x squared in the original problem, this little method, right, what you're looking for, if the 2 terms inside the parentheses are both divisible by something, then that's not the real factor. So in this case, like the 3x and 1 don't have anything in common, but the 3x and the 21, those guys are both divisible by 3, so that's not the real factor. All you have to do to get the real factor is just divide both of those terms. It doesn't come out in front or anything like that. Just divide both of those terms and just kind of disappear that out. The real factor there would just be x and then plus 7. And you could check this super quick. First terms, if you multiply them together, like 3x times x is 3x squared. -1 times 7 should give you the number on the end. So that's really quick to check. If you want to completely FOIL it out, you can, but you don't have to. So I wanted to review one of each of those types with you for the factoring. And we'll do a little bit more with this on the back, but is anybody having a question at the moment? Okay, now we're going to talk about multiplicities real quick at the bottom of the page, but we're going to have an application of that on the back. So a 0, or a root of a polynomial, we would actually have an equation. So it would be set equal to 0. So these are all polynomials we just worked with, but we didn't have any equations. So we're going to do equations on the back. Okay. It's a 0 is the value, I said, of the independent variable. It's usually the value of x that if we were to plug it in would make the equation 0. Okay, also, this is going to be where a graph would cross or touch the x-axis if it's a real number, And this is the important part for this multiplicity discussion. The number of zeros or solutions or roots or whatever you want to call them. They have all these interchangeable names. We'll probably call it a root or a zero. The number of solutions is equal to the degree of the polynomial. So we're going to talk about this more in the back, but it's just the highest power of x. That's how many answers your question should have. Now, what we might have to deal with that is called a multiple zero or a multiplicity. So a multiple zero is a zero, solution, root, whatever you want to call it, and this is not a technical definition, but it basically counts more than once. And when I say counts, I mean in this number, so that the number of solutions you have add up to the degree of the polynomial. So a zero might count in that degree more than once. Now, the multiplicity is just the number of times the zero root solution, or whatever you want to call it, counts. And I'm going to explain this to you like in 2 seconds on the back. It basically has to do, if you have parentheses that have an exponent, that's all it is. It's not a big deal, and it'll match the exponent. So we're going to do that on the questions right after this. Okay. Now, I am not asking you to do this because it would be mean, but these are all equations. Could you tell what the leading term would be if I actually sat there and multiplied that out? So like if I had that 3x minus 2, right, and then we have x plus 2 4 times. What would like the first term be? What do you think? Go ahead. Yes. Okay. So if I actually, like the first term here, this would be 3x to the 5th, right? It would just be the first one. Like, I'm not asking you to multiply this out, but just to get the degree of the polynomial, if I can get that first term, the degree is just the highest power of x. So if you did this, right, you have 3x, and then you have, that would be squared, cubed, 4th, 5th. So it'd be 3x to the 5th. Okay, so what that means is this should have 5 answers, or 5 zeros, 5 roots, whatever you want to call it. Okay. In factored form, this is super easy for us because we can just set the little parentheses equal to 0. You would like to have this in factored form to do this. So if you got anything in parentheses, multiply together to get 0. Either this is 0 or this is 0. If you want to make yourself like a little equation, you could just set 3x minus 2 equal to 0. I usually just try to do it in my head, but I would add 2 and divide by 3. So one of the solutions there is going to be 2/3. The other solution, just x plus 2, to make that 0, we would plug in -2, right? And I just told you I'm supposed to have 5 answers. So I just have 2 different numbers there. So this is the deal with the multiplicity thing I just mentioned to you. If you have an exponent, so that has x to the 4th power there, this -2 would have what we call multiplicity. I'm just going to use a little lowercase m of 4. So that, I know it's weird, but that actually would count as 4 answers. So that way this is 4 answers, this is 1, 2 different numbers, but it technically counts as all 5 answers so that we fit that rule that the number of solutions matches the degree. So if you see an exponent, that's just going to be a multiplicity on that 0. That's all you have to do. So like if I look at this one, I'm not going to write this out, but think about this for a second. You have 2x. Then I'd have x plus 6 3 times. And then I would have x minus 7 twice. So anybody know what power of x, if I multiply it, like I kind of wrote that out up here. If I multiplied that all out, what would the exponent be? 6. Okay, so this doesn't matter about the 2. This should have 6 answers. Okay. So if I look at this, again, just if you want to set the parentheses equal to 0, I just kind of think it through in my head. So if I have 2x plus 5, I know if there's a number in front of an x, it's going to have a fraction. Just like all I would do here, I'm thinking like, okay, I would subtract 5 divided by 2. So 5 over 2. Now, that's just 1. There's no exponent, so that doesn't have a multiplicity, or you could say multiplicity of 1. They don't technically do that unless it's more than 1, but just 1 0 there. Now, this guy right here, if I have x plus 6, we'd plug in negative 6, but because that has an exponent, that has a multiplicity. And the multiplicity is just the same thing as the exponent, which is 3 there, and so that would count 3 times. So I have 1, then this would be 3 more, so that'd be 4 answers. We're supposed to get 6. Now, the last one, I have x minus 7, so we would plug in positive 7. That has an exponent of 2, so that has a multiplicity of 2, so it counts twice. And there's all 6 answers, right? This counts twice, this counts 3 times, this just counts once. You don't have to have a multiplicity. Not all these questions will, but if they do, it's just to help to add up to the number of zeros you're supposed to have. Now the last one is a little bit weird. So can anybody tell me what the first term would be here if you multiplied out? I've got negative 2x squared, and then I've got an x squared minus 64 in parentheses, and I got an x plus 5. What would it would be negative 2x to what power? You can figure it out. Just multiply the first term in each thing. What would the exponent be? It'd be 5. Yeah, okay. Here's x squared, x squared. This is just an x. You don't have any of the parentheses with a squared or something like that on it. So this is just like 2 here, 1 here. So this would be x to the 5th. All right, so this is going to have 5 answers. Now, out in front, I have negative 2x squared. What would you plug in for x that would make that 0? Just 0. Exactly. Okay, now, that's a little bit weird. Don't worry about the negative 2. If you have x squared, because it's squared, it's outside, it's not in any parentheses, right? X squared, this would have a multiplicity of 2. All right, so that counts twice. Now, this one right here is weird. That exponent is inside the parentheses. So I need x squared minus 64 to be equal to 0, to make the whole thing equal to 0. How would you solve that little equation? I got x squared minus 64 equals 0. You're going to add 64, right? How do I get rid of the square root? Fail. All right, I get rid of the squared by taking a square root. Sorry, spoiler alert. All right, what do I need to put in front of my answer? Plus or minus. So this is actually 2 different answers. So square root of 64 is 8, right? So we could get 8 or negative 8. So I've got 2 answers here. This is 2 different answers, positive 8 and negative 8. And then on the end there, we would just plug in negative 5. That doesn't have any multiplicity. These do not have a multiplicity. It's just 2 separate numbers, 8 and negative 8. The only multiplicity on this one is on that x squared that's out in front by itself. That means my 0 of 0 has a multiplicity of 2. So 1, 2, 3, 4, 5. And I'm supposed to have 5. Is anybody having a question? Okay. Now, I'm going to give you the answer. And we're going to write the polynomial, and it just says in factored form. Okay, so if I have a polynomial equation and these are solutions, every single one of these should be an equation that's set equal to 0 because these are actual answers that we would plug in. All right, so basically I'm going to tell you the answer. You're going to tell me the little set of parentheses. So if I have 4 as an answer, how would you write that as a factor? Positive 4 is my answer. How would you write that in factored form? X minus 4. All right, what about negative 3? X plus 3. What about 2? X minus 2. Done. That's it. All right, what if 0 is one of your answers? We only want to use exponents if we see information about a multiplicity. So if you just see 0, totally fine, plain by itself, you can just use an x. Don't put an exponent on it unless it has a multiplicity. That's a really good point to make. All right, positive 3, we would just go x minus 3. Now, if we have a fraction, it's a little bit weird to kind of reverse engineer that. So if I have positive 2/5, first of all, I know in between the two it should be subtraction, because that would mean I'm going to add and divide, so I'm going to get a positive number. So it should be the opposite operation. How would you set up that factor if it was 2/5? Yes. Okay, be 5x. Sorry, I wrote that too close to the parentheses. So 5x minus 2. You would add 2, divide by 5. Just to help you out with the fraction, whatever is in the denominator, you're going to multiply by x. I probably should have put a dot instead of x by x, but multiply by x. And then if it's positive, you're going to subtract that number. If it's a negative answer, then you're going to add that number. So whatever's on the top of the fraction gets either added or subtracted. Whatever's in the bottom of the fraction would get multiplied by x. All right, so try it with this one. What would you, how would you write negative 1/2? 2x plus 1. Okay, now, then it says 3 with a multiplicity of 2. All right, so here's all you have to do. 3, so it'd be x minus 3. If it gives you a multiplicity, you just put that on an exponent on those little parentheses. Is that what you're going to ask? Okay, so how would I write 4/3 as a factor? 3x minus 4. Okay, how would you write 7? X minus 7. Okay, now it says 0 with a multiplicity of 4. I probably should have put that at the beginning. Okay, so I'm going to sneak an x here out in front to the 4th. So if 0 is one of your solutions, you just put an x. And then because it says multiplicity of 4, I'm just going to put an exponent of 4. So if you have a multiplicity, just use that as an exponent either on your parentheses or, like I said, if zero's one of the solutions, we do it like that. Okay, here's all we're going to do at the bottom. These are all in standard form. We're going to solve these equations real quick. Now, I can immediately tell you how many answers are supposed to have to this question just by looking at the highest power of x. It's supposed to match the degree. So like if I could do all these real quick. Like this first equation, I have x to the 6th, so I should have 6 answers. Second equation, I have x to the 5th is my highest power, so I should have 5 answers. Last one, 2x to the 3rd, so I should have 3 answers. Now we're going to find those answers. Easiest way I can tell you to do that is by factoring if you can factor. So what can I take out of all the terms in that first example? X to the 4th, right? Now left over we'd have x squared minus x minus 12. All right, so whatever's in the parentheses, we're going to be able to factor further. For this question, I'm just looking inside those parentheses, I'd want to multiply to get negative 12 and add to get negative 1. Can you think of two numbers you'd multiply them, it'd give you negative 12, but when you add them, it'd give you negative 1? So I got 1 and 12, 2 and 6, 3 and 4. What do you think? Negative 4 and 3. Okay, so one of these is x minus 4, one of these is x plus 3. If you're in factored form, you just go through each of the factors, tell me what you would plug in to make that 0. So out in front, this would be 0, but, because, bless you, we have an exponent of 4, so basically that counts 4 times. I'm supposed to have 6 answers, there's 4 of them right there. Now, this set of parentheses, we just plug in positive 4, so there's my 5th answer. X plus 3 would be negative 3. That's my 6th answer. So 4 here, 1, 2. So 6. Those multiplicities just help you add up to the degree. All right, let's try and factor this one. We have at least x to the 3rd in each of those terms. Left over, I'd have x squared minus 49. Tell me two numbers that multiply to get you negative 49 and add to get you 0. 7 and negative 7. So one's a plus 7, one's a minus 7. One of each cancels out that middle term if you were to do a FOIL. All right, so I'm supposed to have 5 answers here. So we have 0, but that has a multiplicity of 3. So that counts as 3 answers there. Then you have negative 7 and positive 7, and that adds up to 5. All right, now I've got one more here. You can't do this on the front because we didn't have equations. But if you have a number in common between all the terms, which I do on this question, I would just get rid of it if you are working with an equation. You cannot do this with a variable, but you for sure can do it with a number. So let's just get rid of the 2. So really this problem is x cubed minus 6x squared plus 18x. Okay, you can't do this with a variable. So that's why if you do have a greatest common factor that is a variable, you're going to pull that out in front. Wait, what? Oh, fired. I thought somebody said plus minus. I was like, I didn't take a square root, did I? No, all right, my fault. Okay, so I need that x out in front. You cannot divide both sides by x. You can do it with a number, but you cannot do that with a letter. All right, now, we'd have x squared minus 6x. Sorry, that should be plus 9. And I think I can squeeze this on the bottom of the page. Tell me two numbers, when you multiply them, you get positive 9. You add them, you get negative 6. This is actually one of those perfect square trinomials. Those are exactly the same. So, okay, I could write that as x minus 3 squared. So that just means that 3, I'm throwing things, has a multiplicity of 2. All right, so we're supposed to have 3 answers, right? 0 is one of the answers. There's no exponent in that situation, so just one answer. I get 3, but that has a multiplicity of 2 because you saw that factor written twice. I squished it together. You could write it in either form if you wanted to, but just know if you have more than one of the same factor, that means it's got a multiplicity. Is anybody having a question?